Hi, welcome to Liber Computers, where learning is fun. In this session, we will learn the OSI model. OSI stands for Open Systems Interconnection, and is a conceptual framework for how applications communicate over a network. The OSI provides a standard for different computer systems to be able to communicate with each other. It's based on the concept of splitting up a communication system into 7 abstract layers. The OSI model layers are typically described from the top layer down. These layers are provided by a mixture of network card drivers, operating systems, applications, and networking hardware that facilitate the transmission of signals over Ethernet and Wi-Fi. The application layer interacts directly with the data and user software applications like the browser and email clients. The application layer provides network services to the end user. These services are protocols that work with the data the client is using. The protocols are HTTP that is used with web browsers such as Google Chrome, Firefox, and Internet Explorer. Other examples of applications that use this layer are Office, Outlook, and Skype. All of those interactive applications provide a set of services that allow the application layer to supply data to and receive data from the presentation layer. Presentation layer is responsible for preparing data so that it can be used by the application layer. The presentation layer, or layer 6, performs the uncomplicated task of syntax processing, or converting data from one format to another. This layer handles translating the data from the top layer, which is presented in application format, to network format and vice versa. After the presentation layer processes the data from one format to another, the information is then passed to the session layer or the application layer. Session layer responsible for opening and closing communication between the two devices. The time between when the communication is opened and closed is known as the session. The session layer ensures the session stays open long enough to transfer all the data being exchanged, and then promptly closes the session, in order to avoid wasting resources. After the session is established, the data then passes to or from the transport layer. Transport layer is responsible for end-to-end communication between two devices. This includes taking data, breaking it up into chunks, called segments, before sending it to layer 3. The transport layer is also responsible for flow control and error control. It regulates the size, sequencing, and ultimately the transfer of data between systems and hosts. The best known example of the transport layer is the Transmission Control Protocol, TCP, which is built on top of the Internet Protocol, IP, commonly known as TCP/IP. TCP and UDP port numbers work at layer 4, while IP addresses work at layer 3, the network layer. The network layer is responsible for facilitating data transfer between two different networks. The network layer, or layer 3, handles the routing of data. The network layer breaks up segments from the transport layer into smaller units, called packets, on the sender's device, and reassembling these packets on the receiving device. The network layer finds the best physical path for the data to reach its destination. This is known as routing. The data is then passed to the next required layer, which is the data link layer. The data link layer is very similar to the network layer, except the data link layer facilitates data transfer between two devices on the same network. Two sublayers exist here as well: the Media Access Control (MAC) layer and the Logical Link Control (LLC) layer. The layer sets up links across the physical network. When this layer receives data from the physical layer, it checks for transmission errors and then packages the bits into data frames. An example of the MAC layer includes 802.11 wireless specifications as well as Ethernet. The data link layer sees the error control and intranetwork communication. This layer includes the physical equipment involved in the data transfer. In this layer, the data gets converted into a bit stream, that is 0 and 1. The physical layer, or layer 1, is the electrical/physical layer of the model. This layer encompasses the network cables, power plugs, cable pinouts, wireless radio frequencies, connectors, transceivers, receivers, repeaters, pulses of light, electric voltages, etc. At this layer, the model transmits the digital data bits from the source or sending device's physical layer, over network communications media. In this session today we have learned the OSI model. Thank you for watching our video. Like, share, and subscribe our channel.